Welcome to today's session on indicators of attack, indicators of compromise, and threat detection. I'm excited to guide you through these critical concepts that form the foundation of proactive cybersecurity defense. By the end of this lesson, you'll be able to distinguish between IOAs and IOCs, understand threat detection methodologies, and apply these concepts to real-world scenarios, all essential skills for your CYS A+ certification. Today's content directly addresses CYS A+ exam objectives 1.2 through 1.5, covering threat and vulnerability management. Let's dive in and build your defensive cybersecurity toolkit. Animating in. Let's begin with indicators of attack, the early warning signs that can help us stop threats before they cause damage. Indicators of attack, or IOAs, are the breadcrumbs attackers leave behind as they're actively conducting their assault. Think of them as real-time warning signs that something malicious is happening right now. Unlike indicators of compromise, which we'll discuss shortly, IOAs focus on the attacker's tactics, techniques, and procedures, their TTPs, while the attack is in progress. Let's break this down across three key categories: network-based IOAs, endpoint-based IOAs, and application-based IOAs. On the network side, watch for unusual traffic patterns. This includes unexpected spikes in outbound connections, especially to uncommon destinations. Beaconing behavior, where a compromised system checks in with a command and control server at regular intervals, is a classic network IOA. You might also see anomalous DNS queries, port scanning activities, or data exfiltration attempts characterized by large outbound data transfers to external IPs. For example, if you suddenly observe a workstation making hundreds of DNS requests to newly registered domains, that's an IOA screaming for attention. Moving to endpoints, your workstations and servers, IOAs manifest differently. Look for unauthorized processes running with elevated privileges, unexpected scheduled tasks being created, or modifications to system files and registries. Rogue devices appearing on your network, especially those attempting to mimic legitimate systems, are clear IOAs. Lateral movement is another critical endpoint IOA. When you see authentication attempts from one internal system to another in patterns that don't match normal user behavior, investigate immediately. At the application layer, IOAs include authentication anomalies like multiple failed login attempts followed by a success, privilege escalation attempts, or unusual API calls. Log tampering or deletion is a major red flag. Attackers often try to cover their tracks by altering logs. Watch for application errors that spike suddenly, or unexpected changes in application configuration files. These can indicate an attacker is manipulating your applications for malicious purposes. Take a moment to think about this question. Pause the video if you need to. Remember what we've learned about the timing and nature of IOAs versus IOCs. That's right, it's an IOA. Those outbound DNS queries represent suspicious activity happening in real time, showing the attacker's technique as they attempt to establish communication or exfiltrate data. Great job. Now that we understand IOAs, the signs of active attacks, let's shift to indicators of compromise, the forensic evidence that tells us a breach has already occurred. Indicators of compromise, or IOCs, are the forensic artifacts left behind after an attack. These are the smoking guns that confirm a security breach has occurred. While IOAs help us catch attackers in the act, IOCs help us understand what happened, how deep the compromise went, and how to remediate. IOCs come in many forms: malware signatures, file hashes, suspicious IP addresses, domain names, email addresses used in phishing campaigns, and unusual user behaviors documented after the fact. One of the most common IOCs is malware itself. When we detect malicious software, we use sandbox tools to analyze it safely. Tools like VirusTotal, Joe Sandbox, Any, Run, and Cuckoo Sandbox allow us to detonate malware in isolated environments and observe its behavior without risking our production systems. These tools generate detailed reports showing file hashes MD5, SHA-1, and SHA-256, which become IOCs we can use to detect the same malware elsewhere in our environment or share with the security community. Let's walk through the abnormalities together. First, notice the from address. It's using a slightly misspelled domain, a common phishing tactic called typo squatting. Second, the received headers show the email originated from an IP address in a geographic location that doesn't match the supposed sender. Third, the reply to address is completely different from the from address, a major red flag. Finally, look at that message ID. The domain doesn't match the sender's domain. Each of these elements becomes an IOC. The malicious domain, the suspicious IP address, the fraudulent email address, all can be added to your threat intelligence feeds and block lists. Beyond technical artifacts, behavioral anomalies can be IOCs too. A user account accessing files they've never touched before, login times that don't match the employee's known schedule, or data access patterns that deviate from baseline behavior. These are all indicators that an account may have been compromised. This is where SIEM systems and user and entity behavior analytics tools excel. They establish baselines of normal behavior and alert us when deviations occur. Understanding IOAs and IOCs is crucial, but detecting them effectively requires structured processes. Let's explore threat detection methodologies and how we continuously improve our defensive capabilities. Effective threat detection isn't random. It follows proven methodologies and structured processes. Let's explore the intelligence cycle, different approaches to threat hunting, and how we continuously refine our detection capabilities. The intelligence cycle is a systematic approach to gathering, analyzing, and acting on threat information. It consists of 6 phases that form a continuous loop. First is requirements, defining what information we need, what threats are relevant to our organization, what assets are we protecting. Second is collection, gathering raw data from various sources, logs, threat feeds, security tools, open source intelligence, and more. Third is processing, converting raw data into usable formats. This might involve parsing logs, normalizing data from different sources, or enriching indicators with context. Fourth is analysis, the critical thinking phase where we identify patterns, correlations, and threats. This is where human expertise shines. Fifth is dissemination, sharing intelligence with stakeholders who need it in formats they can act upon. A technical team needs different information than executive leadership. Sixth is feedback, learning what worked and what didn't, then using that knowledge to refine our requirements. This loops back to step 1, making the cycle continuous. Organizations that excel at threat detection follow this cycle rigorously, constantly refining their approach based on lessons learned. Threat hunting is proactive, searching for threats that have evaded automated defenses. Unlike reactive incident response, hunting assumes compromise and seeks to find it. There are two primary approaches: assumption-based hunting and intelligence-driven hunting. Assumption-based hunting starts with a hypothesis. I assume attackers might use PowerShell for fileless malware attacks on our endpoints, for example. Hunters then search for evidence supporting or refuting that assumption. This approach is creative and can uncover novel attack methods, but it requires experienced analysts who understand attacker TTPs. Intelligence-driven hunting uses threat intelligence to guide the search. If we receive intelligence that a threat actor is targeting our industry using specific malware, we hunt for IOCs associated with that malware in our environment. This approach is more focused and efficient, leveraging the knowledge of the broader security community. The best programs use both approaches. Intelligence gives us known threats to hunt for, while assumptions help us find the unknown unknowns. Detection and hunting aren't set it and forget it activities. We must continuously improve our processes. This starts with metrics. Track your detection rates, false positive rates, mean time to detect, MTTD, and mean time to respond, MTTR. What's working? What's not? Conduct regular retrospectives after incidents. What did we miss? How did the attacker get in? What could we have detected earlier? Turn lessons learned into new detection rules, hunts, and IOCs. Participate in purple team exercises where offensive and defensive teams collaborate. Red teamers simulate attacks while blue teamers detect and respond, creating a feedback loop that strengthens defenses. Finally, stay current with threat intelligence. Attackers evolve constantly. Our detection capabilities must evolve too. Subscribe to threat feeds, follow security researchers, and participate in information sharing communities like ISACs. Let's practice these concepts. If you're in a group, divide into two teams. Team 1, you're doing assumption-based hunting. Come up with a hypothesis about how attackers might target your organization and what evidence you'd look for. Team 2, you're doing intelligence-driven hunting. I'm giving you this IOC, a suspicious IP address 192.0.2.47, reported in a threat feed for ransomware activity. How would you hunt for evidence of this IP in your environment? Take 5 minutes to discuss your approaches with your team. If you're studying alone, write down your hunting plan for both scenarios. Excellent work. For Team 1, a strong hypothesis might be attackers could exploit our public-facing web applications to gain initial access. You'd hunt by examining web server logs for SQL injection attempts, file inclusion attacks, or unusual post requests. For Team 2, you'd search firewall logs, proxy logs, and CM data for any connections to that IP, then pivot to investigate any systems that contacted it. Theory is important, but nothing beats hands-on practice. Let's look at how you can apply these concepts in a real environment. To solidify your understanding of cyber threat intelligence and detection, I'm assigning a practical lab exercise using TryHackMe, a popular cybersecurity training platform. The lab is called Intro to Cyber Threat Intel, and it will walk you through the intelligence cycle we just discussed, show you how to use threat intelligence platforms, and give you hands-on experience with IOCs and threat hunting concepts. Here's what you'll do in the lab. You'll learn about different threat intelligence sources, practice using tools like MISP and OpenCTI, analyze real-world threat reports, and extract actionable IOCs from threat intelligence documents. This lab typically takes 1 to 2 hours to complete, depending on your pace. I recommend completing it within the next week while today's concepts are fresh in your mind. The hands-on experience will significantly deepen your understanding and better prepare you for the CSC Plus exam scenarios. To access the lab, go to tryhackme.com, create a free account if you don't have one, and search for Intro to Cyber Threat Intel. The lab is free to access. I challenge each of you to complete this lab before our next class. Come prepared to share one key insight you gained from the experience. This practical application will make you a much stronger analyst and test taker. Let's bring everything together and review what we've covered today. We've explored 2 critical concepts that every cybersecurity analyst must master: indicators of attack and indicators of compromise. Remember, IOAs are the real-time warning signs of an active attack. The attacker's TTPs in action: network anomalies, unauthorized processes, suspicious authentication patterns. These are IOAs that help us stop attacks in progress. IOCs, on the other hand, are the forensic artifacts that confirm a breach occurred. Malware hashes, malicious domains, suspicious IPs, and behavioral anomalies discovered after the fact. These are IOCs that help us understand the scope of a compromise and prevent future attacks. We explored threat detection methodologies, particularly the intelligence cycle that guides how we collect, process, analyze, and act on threat information. This systematic approach ensures we're not just randomly looking for threats, but hunting with purpose and strategy. We discussed 2 approaches to threat hunting: assumption-based, where we start with a hypothesis and search for evidence, and intelligence-driven, where threat intelligence guides our hunting efforts. Both are valuable, and mature programs use them in combination. Finally, we emphasized continuous process improvement, tracking metrics, learning from incidents, conducting purple team exercises, and staying current with evolving threats. Threat detection is never finished. It's an ongoing cycle of improvement. Now, let's test your understanding with a few review questions. The answer is IOA. This beaconing behavior indicates an active command and control connection happening right now. This is an IOC. The malware is a forensic artifact from a breach that occurred in the past. We need to investigate the scope of the compromise, requirements, collection, processing, analysis, dissemination, and feedback. This cycle continuously loops to improve our threat intelligence. This is a behavioral IOC suggesting account compromise. Investigate immediately. Check for other suspicious activity from this account. Verify the user's physical location. Review authentication logs, and consider temporarily disabling the account pending investigation. Thank you for your focus and engagement today. You've taken an important step in your cybersecurity journey by mastering these fundamental detection concepts. Understanding IOAs and IOCs, applying structured threat detection methodologies, and continuously improving your processes are skills that will serve you throughout your career, and they're critical for success on the CSA Plus exam. Before our next session, please complete 3 things. First, review your notes from today's lesson. Repetition is key to retention. Second, complete the Try Hack Me lab we discussed. The hands-on practice will cement these concepts in your mind. Third, start thinking about the relationship between detection and response, because that's exactly where we're headed next. In our next session, we'll dive into incident response, how to effectively contain, eradicate, and recover from security incidents. We'll explore incident response frameworks, roles, and responsibilities, and the critical decisions analysts must make under pressure. Everything we learned today about detection feeds directly into our response capabilities. Keep up the excellent work. You're building a strong foundation for a successful career in cybersecurity. I'll see you next time.